Tuttle here for Ferguson Roof Systems. For 43 years, Ferguson Roof Systems has been protecting Oklahoma's homes and businesses with quality roofing services. Their goal was to be the most honest and dependable roofing company in the state, all while providing free services such as lifetime labor warranty and annual inspections. Well, mission accomplished with thousands of client testimonials, an A+ Better Business Bureau rating, and a 5-star rating on Google. Look, the weather gives you enough to worry about, so why worry about who to trust with your roof? Call Ferguson Roof Systems today or find out more at fergusonroofsystems.com.
Hey everyone, Meteorologist Aaron Tuttle here with you. It is 4:30 on the afternoon here as we head into our winter storm region as that stuff moves in from the south. Let's take a look at what's happening here on the radar viewpoint. And we're going to try and give you the update on how things are looking if you're headed out and about for this New Year's Eve. So we do have some rainfall moving into central Oklahoma right now. So this is just before the 6 o'clock hour, so we're at 4:30. And a lot of this on the north side isn't quite reaching the ground yet, so it's going to take a little bit of time for the atmosphere to saturate. But down in Norman, it is reaching the ground. So we've had reports even of some freezing rain already beginning down here around the Norman area. Even some rain being reported now around the south end of town around Moore. So these are all ping reports that are coming in from just users. So now when they report rain, I'm not sure about the how well the user checked it out to see if it was freezing on contact or not. But because there's been little of these mixed in, and so most of all this should end up being freezing rain reports as we go through our evening. But to let you know that the rain is moving into the south side of town, it's only going to continue to get heavier with time. And the algorithm trying to flip it over to freezing rain here, we see the orange on the map. And that's because temperatures are getting a little bit colder. Let me see if I can turn on some of these. Let's see, that's not on. Let's do this one. So for example, down here in this region in Purcell and Pauls Valley and Wayne, you're about 32 degrees over a dew point of 28. So in other words, that's cold enough to start to see freezing rain. You're wet bulbing probably closer to about 30 degrees in this area once the atmosphere fully saturates. So this is where the developing ice storm is occurring here south of Oklahoma City metro area, and all of this is moving up to the north. So it's just going to be a matter of time before our bridges and overpasses will start to get coated with some ice, and that'll be after dark, and it may be just a little bit in the early evening hours, say maybe 7 o'clock or something like that. It's going to be hard to tell on the timing, but it won't take long. And if you're going to be out and about, you're just going to be careful. But that's how things look right now. And of course, this extends all the way down to Texas. Just the rain itself. Temperatures are much warmer down there. Now, you see this little blue line. This is a discussion from the Storm Prediction Center. And in that, let's go over here to this one. What they're talking about is the fact that freezing rain is developing and moving through. So that's nothing new, but that's just where they put it. The watch hazards really extends all the way from the Big Bend of Texas. This is winter storm warning in pink, all up into central Oklahoma and even into Kansas and Missouri. It does cut off there, so I'll go to the northern view of that just to show you it continues all the way across most of Missouri and then on north and east from there, even an ice storm warning in Illinois. So there will be a plethora of colors on the map indicating different types of warnings over the period of this next, let's call it 24 hours in this area you see highlighted here. Okay, so let's go move on. Whoa. Let's see, the actual storm system is down here into central Texas now. So it has moved out of Mexico from lunchtime, is now moving here into southwest Texas. So this would be the center of the upper level low right about here. And you can see all the moisture that's coming out in advance of it just piling right here in Oklahoma. So that's saturating our atmosphere and getting that precipitation to develop. So this is the beginning of the storm system as it moves on in. As we talked about, temperatures are into the mid 30s here across the state. Dew point values in the low 20s, upper 20s down just south of the metro. I remember yesterday, last night, and around lunchtime today, we talked about how, and even last night, how we talked about the dew point values are completely missed by the model data. That's far drier in the atmosphere, so that's going to help the freezing rain threat to materialize here over central Oklahoma and even stretching up toward Tulsa. And we'll get to that here in just a second. Here's a breakdown here of Oklahoma. And as we mentioned earlier, how the National Weather Service would extend the winter storm warning eastward and southward, and that's exactly what they did. Pretty much right along the line where I had drawn it for you earlier. So it's Osage County down to Stillwater, to Oklahoma City, to Chickasha, back to Lawton, and then on to Wichita Falls. Again, peppered in this, we might get a few other warnings thrown in. It kind of depends on how the system evolves. And this winter weather advisory likely be extended to include Tulsa County as the event unfolds. That'll be shortcoming. Precipitation amounts. The Weather Service has gone very, very conservative on the ice accumulations, but they have changed and shifted everything to the east to better match the model data. So really stretching from Tulsa down the I-44 corridor all the way back to Lawton and Altus, and these amounts could easily be double this. So in other words, up to about half an inch. I think at the most worst case, about half an inch of ice. So this is a conservative estimate, and not a bad one, just not all to the fullest potential of what's coming out. There's a lot of precipitable water with this event. And even snowfall amounts, although 4 to 6 is a good conservative number, there are going to be pockets in here that could be double this. The best location for that would probably be Western Canadian County, probably up to Kingfisher, Enid, something like this, back out to say maybe in this zone. Or it could even extend maybe something like this. It's just going to be west side of Oklahoma City, and then points north is a better zone to see this number right here, 6 to 8 inches of snow. And yeah, we might have some isolated spots get a little crazier than that. But we also have the ice to deal with. And I'm going to show you a couple of the model data reports so we can get a better idea of how things are really looking. So let's do that now. And I also want to show you why we're going to be getting this issue of ice rather than snow. We're going to do that in more detail. And I'm going to do that by showing you a particular map. So when we talk about the warm nose at 850 millibars, I want to show you what that looks like on a flat two-dimensional plane. And this kind of tells the tale. All right. Okay, so let's put this in motion. We'll start at time 0, which is lunchtime. The low, 850 millibar low, is down here just southwest of San Antonio. It's going to drift up to the north like this. So that's what we're going to watch for. So as I step this forward in time, let's see, we're 0Z. All right. Now the cursor readout, if you can see it, in this area of green in yellow, this is 10 degrees Celsius, 7, 6, 5, 4, 3. This is above freezing. This is that warm nose. This is level at 850 millibars. It's several thousand feet off the ground. But it's what warms the snow and melts it into rain, which then refreezes on contact. Now there is a little thin band here of where it says 0 degrees in the model data. We'll discard that for now because I want you to see the bigger evolution of what's going to take shape. Now this is at 6 o'clock this evening. We go to 9 o'clock this evening. That little batch of colder air has shifted into western Oklahoma, which makes it easier to get more snow out once you get west of the metro. And what we've replaced it with here in Oklahoma City is plus 4 degrees. It's plus 7 or 9 down here in Norman. Very, very warm. That means it's a freezing rain event and some sleet. And then we head into the midnight hour here in Oklahoma County. We're at plus 7 degrees. So this is at the point in time where the upper level low is now moving out of the Dallas-Fort Worth area, is moving up toward the Denton region and Gainesville, about to approach the Red River. So what's going to happen here, as this low deepens and strengthens, which it will do from this point forward, what you're going to watch is cold air transfer down through the column. So a low is stretched vertically. So I'm just picking one cut, one layer, and we're looking at a flat view. But the low actually extends all the way down. So what we're going to watch is cold air up here being transferred down through different processes in the atmosphere, and you're going to watch that column cool, including the 850. So let's take a look here. So that will overcome what we call warm air advection, which is the southeast and easterly wind at 850. So here's a look at the next step. This will take you to 3 o'clock in the morning. You see what happened here from midnight to 3? So the low is now still over here in the Red River area, and we've expanded and taken over the warm air advection due to the cold pool cooling down. So that's how you transfer over to snow. But that won't occur until we get probably right around 2 o'clock in the morning here in central Oklahoma and Oklahoma City metro area. Here in Tulsa, you're still at +2, so anything at this point in time should still be in the form of freezing rain and sleet. Now we go one more time to 12 o'clock Friday morning, and you can see that cold air is everywhere. I mean, it's -4, 0, minus, even Tulsa. So that's where has really expanded the cold air. You'll also notice that a lot of this blue, which is all below 0, has continued out here in western Oklahoma. And that means it's easier to get snowfall amounts to pile up where you have that hard cutoff line for the freezing rain. So I'll backtrack to midnight and give you an example of that. So here in Oklahoma City, I mean, like I said, we're +7. It's heavy freezing rain at that and some sleet. Once you get back out west, it's +3. So there's going to be a little nose of warm air before this erodes, even out here, to get some freezing rain and sleet. But it quickly fills in, most of it anyway, with temperatures should be at or below 0. And that just kind of continues to fill in for the Friday morning time frame. So we have a lot more hours overall in a freezing rain and sleet scenario than we do a snow scenario. That means in general terms, the snow should be less and the freezing rain should be more, which is why I'm more confident and been leering more toward a ½ inch of ice than I have on the lower threshold, just because of the time under the warm air advection. All right, so let's get to the latest HRR map. This is the latest HRR. So we do know the precipitation is already moving in, so let's see what else we don't know, right? All right, so let's go to the latest hour. This model updates every hour. So we got some light precipitation here moving into southern Oklahoma. That pink, here's 5 o'clock, indicates the freezing rain that is mixing in. So the model's picking up very well on actual current conditions. That's a good sign. You want to make sure the model that you're using actually knows what's going on when you look out the window. It's got to match. So as we head into 6 o'clock, it continues to progress to the north. It's having a tough time getting too far north. You can see it's barely making it out of Oklahoma and Canadian County. It's kind of putting the brakes on, right? But boy, it's freezing rain to beat the band here. We'll go through another time frame. Here's 8 o'clock. 9 o'clock now, we're really starting to fire things off. By the way, Tulsa, even though it shows green, I think you're going to get a little touch of freezing rain here during the early evening hours. It may warm a little bit as some of that warm air kind of transfers down as we get later in the evening around midnight, but then on the back end, it will get cold again late tonight into tomorrow morning for your snow opportunities. But you might have a little touch and go for several hours here this evening. Okay, so that's 8 o'clock, 9 o'clock, doesn't get any better. There's 10 o'clock, look at it expand. That's all ice, freezing rain, and sleet. Sleet, those little clear balls that bounce. What they do is cause slippery bridges and overpasses. Otherwise, they're just a nuisance. It's the freezing raindrops that freeze on contact, which will hit the trees, power lines, bridges, that kind of deal. Main roadways should be okay for the most part for this event, at least early on. They may eventually be overcome, especially overnight tonight. So if you're traveling, you're just going to be careful. Ice is not fun, and it's very dangerous to drive in. All right, so here's a look at 10 o'clock and 11 o'clock and midnight. So you can see out here in western Oklahoma, the models are already at midnight trying to get this to transfer over to all snow. We showed you in the upper levels how there's a little battle there of leftover warm air that's going to try to erode here rather quickly. So that leads to a little bit higher snowfall amounts just west of Oklahoma City, which is kind of where I was circling that before at the start of this broadcast. 1 o'clock in the morning, and there's 2 o'clock in the morning. I mean, just heavy precipitation. And then you finally see as that cold air expands, 2 o'clock in the morning, you see how we're getting all this into blue, which is pure snow. As we head into 3 o'clock in the morning, all snow, 4, 5, but it is starting to pull away. 6 o'clock in the morning, most of the heavy snow is starting to move out of Oklahoma City. We'll get some flurries, maybe some light freezing drizzle left over in its wake at 9 o'clock in the morning as this model ends on its run in the short term. So there's Tulsa still getting some snow. Matter of fact, the model for Tulsa, I was kind of focused on Oklahoma City, but if you notice in Tulsa, 11 o'clock, 12 o'clock, this is maybe where you get a little bit of warming overnight for just a few hours. But the models at 2 and 3 o'clock in the morning bring you right back down below freezing. And that's assuming if you even get above freezing, it's going to be close. So there's 3 o'clock in the morning, there's 4, so there's your mixture of sleet, freezing rain, and snow. And then all snow for 5, 6 o'clock in the morning, 7 o'clock in the morning as it pulls away. All right, so now let's look at the latest ice accumulations from this particular model. And now keep in mind, this is a model that had not had any ice at all. It had all snow. And it had like stupid amounts of snow because it didn't understand that our surface temperatures were going to be colder and the air was going to be drier. Now that it's caught on to that, it's gone with the Canadian model, which really led the pack here on this outlook of ice. And it's got half an inch of ice here in Oklahoma City. There's some pockets down to 3/4 of an inch of ice where it's already occurring in south central Oklahoma. So there's another hot spot. Up here northeast Oklahoma, west of Bartlesville, it's got some high pockets in here around half an inch or so, and it's just clipping Tulsa. And I think the model error a little bit, so a safer call would be anywhere from all of Tulsa County, but more favorably on if you cut the county in half and you take the north and west side of the county, more likelihood than the southeast, say around Muskogee or Mogi or that kind of area is uptown. So if you more north and west you travel, the better odds go up. So you're just right on the line. It's such a hard call. Okay, so that is a look at Tulsa for the ice. So you can see this is not good. This is some power outages off and on that we're going to see out of this deal. Once we look into the most snowfall totals, so the models will not know the exact bullseye because there's probably going to be convective elements to this, which convective elements will indicate a little bit of thunder. So you might have some thunder freezing rain or thunder sleet or thunder snow. So don't be surprised. That's what quickly drops a lot of precipitation at once. Now here in Oklahoma City, it thinks we might have some thunder snow at some point in the early morning hours around 2 or 3 o'clock as it transitions over. So it dumps 7 inches of snow right here over the heart of Oklahoma City, literally downtown. Now, this bullseye has moved around in and around Oklahoma County, just east and north and south and west of the last couple of runs. So the model can only hint at the idea that that's in the future. It won't know the exact placement. But according to what I showed you earlier, the hot spot for the most likelihood of that, I drew something like this. And that looks to be the case. So within this region here, actually extended, I think, down toward Lawton. Within this region here is where the best odds likelihood of seeing some pockets of snow that are in excess of 6 or 8 inches of snow. There might be something that's a lot more than that. It's hard to tell. Snow is always a fun thing to forecast. Now, we mentioned also last few discussions about the wind speeds. So if we go look at blowing winds, drifting snow, all that kind of stuff, here in southwestern Oklahoma, there winds of 50 miles an hour expected around 9 o'clock around Lawton. You can see these little pockets of yellow that move through. They're all winds up around 50 miles per hour, and they move into southwest Oklahoma and up central Oklahoma. So if you're getting snow that's blowing snow, it might even be blizzard-like conditions temporarily. Up north and east, you've got 50s up here in northeast Oklahoma too. So a lot of winds going to kind of travel throughout the state tonight. Be extremely windy. That moves on into Kansas and probably even Missouri as this upper level low kind of deepens and then moves across. And then the winds will die down as we head into 9 o'clock in the morning a little bit, but there's still pockets of 40 behind the system as it exits Oklahoma, so a windy day. After this, we will see some snow move through late Friday night and Saturday morning. I think maybe an inch of snow out of the deal. It's going to be a dry, powdery snow over central and northeast Oklahoma. Let me see if I can even find a model that'll even hint at that, because they haven't been too excited about that, but it's going to happen. So let's take a look. I'll go to the 3 kilometer NAM and we'll do a 6-hour window here. We'll see if it picks it up at all. It picks it up in eastern Oklahoma Saturday afternoon as it exits the state, but it doesn't pick it up here in central. Let me try another model. Which one I want to try? Let me try the Canadian. Okay, so there's Saturday morning. So there's 3 o'clock in the morning on Saturday. There's 6 o'clock. There's 9 o'clock, noon, the afternoon. So you can see there's a little signal. There's just some light snow moving through, and at most looks like maybe an inch of snow to fall out of that. It won't be a big deal, but just something kind of to don't be surprised about. Okay, let me see if there was anything else I want to discuss. Let's just go back to, let me do this. Let me see if I can do this. Yeah. Let's see. Don't move fast on my account. Going backwards in time. So this is the forecasted sounding based off the NAM and the high-res version of it. This is a 0-hour forecast. What we're going to look at is that dry level in the atmosphere. This is the dew point, the depression. This is the wet bulb, what happens here in the middle. So the dew point's here on the left, temperature on the right, and when they meet, when the air is completely saturated, it comes down to 31 degrees of the surface. That's how you end up getting the ice. You say, oh, air temperature is 34, what's the big deal? When it starts to rain and it moistens things up, this number here has to move upwards. Well, this number also moves downwards, and they usually meet somewhere not quite middle, but close, and this will be about 31 degrees is what the surface temperature should be once precipitation falls. The other thing we're going to watch for is 850 millibars, is this warm nose, and see how it progresses. This is the, this little line right here is the freezing line. Remember, everything over here, all cold enough for snow, all frozen. Everything over here, just a cold rain. So let's take a look, and we'll step through time. So we are at 7 o'clock. This is a 6 o'clock. This is a 7 o'clock. So the model's a little behind the curve already, remember, because we looked at radar a minute ago. But this is how it shows the atmosphere moistening up. We go to 8 o'clock. The warm nose is still out here. We're below freezing here, and we're right at about 31 degrees wet bulb at the surface. This is 9, 10, 11, 12, same look to the atmosphere, right? This is where we get our elevated instability. This area here, a lot of cape, which means this is where we get our thunder and our heavy bounce. This comes in at midnight tonight, so right on time. You can see the big warm nose here, so that's heavy freezing rain. Might get a little brief transition to some sleet mixed in, but this is mostly a heavy rain profile. We'll go to 1 o'clock in the morning. Now remember, that's when that column starts to cool aloft, right? Well, look what just happened. I'm going to back it up. Here's the midnight hour. So midnight hour, see this warm nose? All right, I'm going to go to, get off of there. You can do it. There we go. So there's the midnight hour. Look how it fell back right along that freezing line. Again, there's 11 and there's 12. So that's an example of how that column cools from the top down, and then that all this lift wants to transfer it over to snow. So this is the profile where you get a lot of sleet and a lot of snow being mixed in. And then you go another hour. This is at 2 o'clock in the morning, and you get pretty much a profile of all snow. And there's still plenty of lift to generate the snow at this point in time. Even still here at 3 o'clock in the morning. And then here's 4 o'clock in the morning. We're still all left of this blue line. But now here's the deal about 5 o'clock in the morning. Most of our lift now is down in the lower parts of the atmosphere, the lowest, say, couple thousand, 3,000 feet, all right? Not up here. And that indicates typically the snow growth zone is up here, all right? And this getting dry up here in the snow growth zone, there's not a lot of lift. And all the lift is down here at the low levels. That means cloudy, some flurries, light, tiny snowflakes, and probably even some drizzle mixed in. So that's what that profile indicates. And that's about 5 and 6 o'clock in the morning here across Oklahoma City Metro. So I think most of our measurable snow will come in that 3 or 4 hour hardcore window, and then it'll continue to taper off throughout the morning. But that's just an example when I show you on a flat plane what it looks like top down in the atmosphere when you're looking at a vertical profile structure. I know it's a very complicated deal, but I'm trying to explain it just so you can understand the process that I look at and how you forecast the weather. I show you a lot of my tricks and things that I look at to provide you with the most accurate forecast I can, from tornadoes to winter storms, that kind of deal. All right, let me see. Let's take a look at the radar and see what's changed. Okay, so we mentioned sleet being mixed in. You see all this little IP on the screen? That stands for ice pellets, or also known as sleet. So we'll move into this one so you can see this a little bit better. This is all up around Edmond right now. So what happens a lot of the times when you're on the northern fringe of the rain shield, so the rain shield is about like this, right? So in other words, heavier rain is hold on, my bad. Heavier rain is here on the south end of town. Let's see, going this way, right? So the northern end of the rain shield is right about here. And it's, of course, all dry north of that. So what happens is when the rain starts to initially fall, it's falling in that dry air. And that helps to form little tiny balls of ice. And these are what we call ice pellets or sleet. So you're getting a lot of sleet reports here on that northern rain band as it moves into the north side of Oklahoma City. Now, why do we not get a lot of sleet pellets up here? Why are we getting them up here? We didn't get them, say, down in Norman and southern parts of Metro when it first started. Because down there, the atmosphere wasn't as dry and the dew points weren't as low. Big difference, obviously, from the southeast side of town to the northwest side of town. So you're getting more of that dew point depression factored in here. Therefore, you're getting more sleet initially. It will transfer over to all ice, by the way, but for freezing rain, I should say. But at least initially, that's how that looks. West side out here in Yukon, there's a report of some freezing rain. If we head down here in the southern parts, down toward Norman, there's some freezing rain being reported in. Let's see here. And these reports down here, they've come in as rain, but I really think some of these are probably going to be freezing rain because there's Ada, and it's got freezing rain coming in, and the computer wants to keep it that way. Let's see here. Let me look at this. So this is interesting too. These little radar where they kind of transfer over using latest model data and temperatures. They try to find out where the rain-snow mix line is. Sometimes they don't quite get it right, but they kind of at least hint at the trouble zone, right? So this little red area is supposedly the sleet zone. And it's close. Sleet zone is actually up here, along this path. And this is actually where it thinks it's snow. So like I said, it's kind of a little goofy, but it's got the right idea of just where precipitation should be, starting to freeze over. And then down here in the pink area is where it's got all the ice, the freezing rain for right now. As temperatures down here wet bulb down to around 30 degrees in this area in Pauls Valley and Purcell, there's 32 over 28, so your wet bulb's about 30. Even down here toward Duncan, it's about, looks like 30 also for a wet bulb. So there you go. So your freezing rain event's ongoing down south. We got a little sleet here across the metro. It's freezing rain also starting to move in. So it's moving in about 1 hour early. I had it in here by 6, so it's in here by 5. So not too bad, but the trend here is to keep going north. Let me take a look at Tulsa. You guys having some rain reports, looks like come in, some freezing, or some drizzle rather. And your temperature is 37 over 21 in Jinx and Broken Arrow. North side of Tulsa, you're 37 over 29, or 37 over 18 rather. Sand Springs, there's 28. What about northeast Tulsa? You're 37 over 27. So when those things wet bulb down, you're going to get a little bit more cold and dry air advection that come in to offset that, because you might be wet bulbing down to about 33 degrees, 34, and that'll be too warm for freezing rain. You might get a little sleet mixed in, but it'll be too warm for freezing rain here in Tulsa. So some things will have to change for that to occur, but you're right there on the border. So it's a tough call up there. Okay, so let me see what else we got here for you. Oh, I know what I want to show you. I'll look at this here real quick. All right. So right now, the atmosphere is uniform from what the radar sees at the shorter distance. It's all the same type of precipitation that extends out a certain range from the radar. Okay, so in this particular case, it's all freezing rain. Where it gets a little bit different colored up here, that's where you get that sleet mixed in, because the precipitation particles look a little bit different to the radar beam. Then once you get out here, you're into the melting layer. So the melting layer is what's shown out in this direction. That's what the snow above it falls through this melting layer, because we're looking This is complicated, but we're looking at a point from a radar, and a radar beam from this point forward goes up. Matter of fact, let me just do this, make this easy for you. So let's see, let's get you a blank map so you're not staring at anything, just to get that off. All right, so now let's have some fun here. So this, no, I don't want that color. I want this color. All right, this is the radar, the old ball in the sky. It's on this little tower and this little base out here, and it's going to shoot out a radar beam, okay? And this, by the way, this is the curvature of the Earth that goes like this. So it's how Earth is round. Well, a radar beam just goes out like this, right? Well, this is the curvature of the Earth down here. So the distance at the end of the radar beam and the Earth is greater than it is right here. So in other words, this radar beam over here could be sampling the air at let's call it 500 feet. And over here, by the time it gets way out in distance, this could be over maybe 1,000 feet, something like that. All right, and then so we're measuring the raindrops and everything else in between at this level. So when I was showing you a minute ago how close in, we'll cut it here, for example. The atmosphere was uniform along this beam, so we're getting solid freezing rain. And then I showed you how it changed colors, right? So let's say, for this sake of purpose, between 500 and 1,000, let's go, I don't want to do that one. Let's do this one. So between 500 to 1,000 in range and distance, so we'll call it meters, call it feet, call it whatever you want to call it. This ends up a difference in the atmosphere. It's up higher. So with it being higher in elevation, in feet, so we'll go 500 feet to 1,000 feet. So being higher in feet, in that column up here, it's actually just snow, or in this particular case, we'll just use snow as an easy example. So what happens is there's a melting layer between the two. So that melting layer has to occur at some point, and when it does, it transitions over. So you'll have different looks on the radar between one level, which can be way up here, and then another level here, and another level here. And so we look at that as a flat picture. I probably lost all of you on this explanation, but I was trying to show it. So if I pan out, this is kind of what I mean by that. This is, so you have one level here. So say this is 500, goes out to 500 feet elevation. The radar beam keeps going. Now maybe this is 1,000 feet elevation, right? And the radar beam went through this whole region, which was melting. Here was freezing rain. This was all melting. And let's say you get out here. What's this layer out here? It's all snow. So you can see how you went from snow to melting to freezing rain. So that's, in other words, this would be regular rain, this would be the freezing rain. So that's kind of how this, when you look up in the atmosphere at stages, things look different with different steps. Now, as a meteorologist, it all makes sense to me. For you, you may be looking at this going, okay, whatever, Aaron. So I didn't mean to do any of this. This is just on the fly. I thought I'd try to explain something. I'm not sure if that worked, but anyway, there you go. So there's your normal map you're used to looking at, which is, okay, show me the radar with rain on it, right? So there you go. And then here's the winter mix moving into central Oklahoma. So a big question, of course, is going to be bridges and overpasses. Yes. Oh, that's what I was going to show you next. So let me do that here real quick. So let's go back here. By the way, I need to do this too. Let me see if this is updated. Always trying to find new tools to use. And that tool is not working. All right, we're going to disregard this one then. Okay, so what did I want to do? I want to go to this. All right, so we're going to go to my website, aarontutterweather.com. We're going to go to the weather data tab. We're going to go to Oklahoma road conditions. And you see temperatures in the low 40s and some 30s. So this is the ground temperatures, actual soil temperatures. So where it's colder, you have a greater likelihood of roads freezing up and snow accumulating. So out here in the west central and western Oklahoma, no problem. Here in northeast Oklahoma, there's a few 30s showing up, but most of us, even in Oklahoma City, look at that, 39, but most of the areas in the low 40s. But these numbers are gradually coming down. So that's what I'm saying. It's usually a timing thing. At some point, everything here gets cold enough to where it can't offset what's falling from the sky. Now, if we go into highway conditions right now and we look across the state, moderate, closed, fog, severe, let's take a look. Nope, everything's still open and moving. And now, this is the fun part. This is where you start to pick out any of these little trucking pictures, and you can blow it up and see exactly what conditions are like. So this guy's driving through rain. You can see nothing there on the roadway that looks like anything menacing. But all the way down I-35 looks like you'll see several of these here. It's like the same guy was just taking multiple pictures on this track. I happen to pick the same dude. That can't be right. There's something wrong with that one. We'll leave those alone. I don't know what's going on with that. That's not how that's supposed to work. But here's another one. So either I just happen to pick that one guy's path the whole way, or I don't know what happened. There's a bug in the system. But here's a look at another guy driving down the road here with rain coming in. And you should be able to see either snow on the ground, or maybe the ice will accumulate in his windshield where the wipers don't hit it. So of course, you'll be able to see the streets and if there's traffic or accidents. So that's one way to do it. And you can do this across the entire state. And then if we go down from there, here in Oklahoma City, here's your all green. And of course, on all these guys, you can also pull up the maps. And here's a look at traffic here. Let me see if I can blow that up. There you go. There's a look at traffic there, and so you can see how well things are moving. So there's a lot of ways to get information. That was the Oklahoma City, but you can also do Tulsa, Lawton, Purcell, statewide. So that's on road conditions. So if you ask me 1,000 times, how's my roads looking? Can I travel this? Can I travel that? My best answer to you always is just to pull up this page. It's on my weather app, AT's Weather to Go. Also my website. It's just called Oklahoma Road Conditions. All right. It's a lot to talk about. If you're going out this evening for your New Year's Eve plans, you're gonna have to just be careful. It's already started. Now, crews will hit those bridges and overpasses, at least in the city, obviously. Outside of that in the country, not obviously so much. So you're just going to have to drive real slow over them. And remember that ice is not controllable in those situations. When you're driving, a lot of cars now are four-wheel drive or all-wheel drive. That really helps out. In the old days, you had a lot of rear-wheel drive cars. There's still some of those out there, but not as much these days. And that was horrific on the ice. Front-wheel drive wasn't too bad, but in those cases, you had to just don't use your brakes a lot. First off, you shouldn't be going fast anyway. And if you're going to brake before you get to the part where there's ice. In other words, approaching a bridge, you don't brake on the bridge ever. You brake before you get to the bridge down to a very low level because you're not sure if it's an ice-coated glaze or not. Other thing you can do is if you're in that position and you're not going too fast, it's a little hard on your transmission, but it's not like you're doing this all year long. You can just downshift from drive to some other level and slow you down that way without having to hit the brakes. So you're gonna have your mechanics going, oh, it's not good for your car. I said, well, you're also only doing it a couple of times. You're not doing it every day or, like I said, all year long. So your car will survive without problems. So that's how that's going to work if you're driving in this stuff. Snow obviously is different. It's easier to drive in as long as your tires are good and your traction's good. There will still be some people that get stuck if it's too tall and you have a low profile vehicle. Now a lot of times, let's say the road temperatures are just warm enough, like the main roads, to not freeze over. Okay, and let's say right around 30 degrees overnight tonight for the heavy freezing rain and sleet. Okay, so let's say ground winds out and only bridges and overpasses. And then let's say we transfer over to heavy snow. All bets are off at that point because when you get that heavy snow that covers the ground, there is an insulation type component to that snow that prevents the top layers from melting and only the very bottom layer melts. And so when that happens, you're actually driving on the new snow, especially if it's coming down heavy, and that can't offset the warming from below. It's a much slower process. So in that particular case, you're going to have some slippery, sloppy roadways from the snow. And that can happen very quickly. That can happen within half an hour of it just coming down. It just depends on the snowfall rate and all that kind of stuff. But overnight tonight, travel will be discouraged here over central Oklahoma, I-44 corridor down southwest toward Lawton, northward up toward 35 to the Guthrie Stillwater, and even out northwest Oklahoma. It's just going to be a mess. So if you can't, stay home. If you can't, I get it. You got to do what you got to do. Let's see here. The radar one more time. It's a lot more ice pellet reports here in central Oklahoma. So specifically Oklahoma County Canadian County, now moving to Logan County, and then a lot more of these freezing rain reports showing up. Eastern Oklahoma County, freezing drizzle. Norman, of course, freezing rain. You're getting more of these down here near Ada, and then also down here near Fletcher. So the storm is underway, my friends, and it looks like it's not going to change. I am going to try something here. I might need to do some type of update to get that to work again. Well, that's just rude. All right, so what I can do, let's try this. Let's see how this works. Okay, so this will at least something. All right, so this will be a split readout. I'm going to show you live dew point values. You're like, why are you showing me live dew point values? What about the temperature? The dew point is the temperature. And when it comes to this type of environment, far more critical than actual air temperature, especially once it starts to rain and precip. So dew point values in the upper 20s here in the light precip that's starting in northern Oklahoma County. It's in the upper 20s. There's 24 down Norman. Pauls Valley is 28, 29. Down around Sulphur, we're looking at 30, 30. So again, what this means is all freezing rain. 27 around here in Lawton, 28. How far does it go? Well, it puts the brakes on, looks like. Once you get to about Eufaula, look at that, you're 32, no sweat. You're all good in Eufaula. McAllister, same idea. You're 33 dew point, no sweat. Atoka, no problem. Even down in Ardmore. Once you get right in the town of Ardmore, what are you? Still, just under 32, but once you get on the south side of town, you are 32. And that continues to get warmer from there into Texas. Durant, no problem in there as well. Back out here in western Oklahoma, dew point values. Binger, there's 28. Weatherford, 27. Of course, up here in northwest Oklahoma, all into the 20s too. So that kind of gives you an idea where the travel spots are going to be. Tulsa, we looked at you earlier. Dew point value about 29, 28 north of you. Your air temperature is a little bit warmer in this area. I don't think I can do both. No, it's one or the other. Yeah, your air temperature down here is around 34, 35. So you're gonna wet bulb down to probably about 30, 32 to 33. Man, it's gonna be so close down there. I just go ahead and assume on the caution side, bridges and overpasses for the evening here in Tulsa. I wouldn't sit there and gamble on a half-degree temperature and go, woohoo! You know, it's just call it good and just say, we're going to prepare for a little ice out there. Okay, so let's see. That was interesting stuff there. What else do we want to show you? I don't think anything on there looks okay. Go back to this guy. By the way, if you're watching in Dallas, nothing's changed. It's just west of you. So it's basically your snow line and ice line. Here's Tarrant County border right here. Here's Dallas County right here. So it's basically in Parker, Palo Pinto, Wise, Hood, Somerville, just west of there. So your snow area is basically along this line and of course points to north in Oklahoma and out west toward Breckenridge and Eastland and Young. So that's kind of the band. It was so close. It's just not going to happen unless that storm track just shifts east 30 miles. If that storm track down here, in other words, that low, instead of it coming across kind of in this area here, if it can come across, say, maybe here, now that's the distance of what, 30 miles or so between here and here. So a 30 mile or so difference pulls this line back to the east 30 miles, and all of a sudden now Tarrant County is in a little bit of that mix. So that's how easy that forecast can change over one spot. And remember, we're trying to track an upper level low that was never quite sampled as well as it could have been coming out of Mexico itself. And so there's always a little sliver of hope, that something could be off and the models all miss it because they just don't know the literally exact track of a 30-mile range. And that is possible even just on a normal storm, much less something that comes out of Mexico. That's what makes these forecasts so difficult when you're trying to draw a line in the sand. You're saying absolutely nothing east of that line and it's all west of that line. you can eat it real quick. When that line just moves 15, 30 miles, and all of a sudden it's either feast or famine for everybody else, who you said wouldn't have a problem or would have a problem. Winter forecasting is very fun, challenging, fickle, interesting, frustrating. It's a lot of things. But it's really neat. It's part of what makes meteorology fun. You get to predict what's going to happen to your best abilities, and then you get to watch it happen. And then at the end of the day, you can be like, not bad. Or you can, at the end of the day, you can go, yeah, I should probably quit my day job. So it's one of those deals. But either way, we get paid. Isn't that the joke? So anyway, so there you go. That is all I've got to tell you, ladies and gentlemen. I don't know if I'll be going live tonight at 9 o'clock, so there may not be anything new really to talk about. I've kind of mentioned everything there already is here on this update. And it is New Year's Eve, so I'll be doing a little celebration as well, of course, like the rest of you. But we'll see. I'll play it by ear. But meanwhile, thanks again for watching. Appreciate you liking and sharing AT's weather to your friends and family. And we'll talk again soon. And be careful out there. Be safe from this winter storm. So remember, up to about half an inch of ice, and then snow. We're looking anywhere from really 2 to 6 inches over a wide area across the central part of the state, stretching down southwest and north and northeast. So Tulsa's around the edge of everything. Oklahoma City's right in the middle of everything. Lawton's right in the middle of everything. But southeast Oklahoma, just a cold rain, it looks like. Timing on this, of course, hitting now, wrapping up through Friday mid-morning to early afternoon. It's out of the state. And then a little light snow Friday night, Saturday morning moving through. Maybe an inch out of that, no big deal. And somebody somewhere is going to get pockets of heavy stuff just because of the convective nature of what's going to happen around midnight to about 3 o'clock in the morning time frame here over central Oklahoma. So that's where you can really crank up the snow totals. You can crank up the sleet or freezing rain. And some of us will be without power after this event, but we'll be thawing out over the weekend, and crews should be able to get to things pretty quickly and get power restored. So should not be a repeat of October. So I'll continue to kind of watch things off and on. If anything changes from that aspect, I'll let you know. But so far, that's kind of been my forecast the last couple of days, and I don't see any reason to change it even up to this point. But we'll see. All right, you guys have a great night, and be safe. We'll talk soon. Take care.